So now you likely see what I mean by these problems. There's no set thing, set roadmap that I can give you, no set step-by-step process. But there are ideas, and I like to think of those ideas, again, as a toolbox. And notice that we've used all of these toolbox except even and odd. We did not use the even odd tool. So maybe it's worth it to say when you're going to use this even odd tool, when you see something like sine of minus x or cosine of minus x or tangent of minus x, that's when you'll use the even odd tool. But every other one we used reciprocal, Pythagorean, common denominators, factors, canceling common factors, dividing fractions, difference of squares, and foiling. And now hopefully you see what I mean by you have to be strong both in your trigonometry, because you need to be able to recognize what trigonometric identities to use, but you also have to be strong in your algebra skills. So if there was a particular algebra skill that you felt you wouldn't have been able to do, I encourage you, go check out the book in whatever you feel like you need to improve. If you need to improve your factoring, there's lots of examples of factoring in the book. If you need to improve on recognizing difference of squares, you can do that. And finally, one more tip that I'd like to give you is make sure you're not using fake algebra or incorrect algebra. So let me give you a practical example of this. So sine x plus 1 over sine x. What I see from a lot of students is they'll say, okay, I'm going to cancel out the sine x. So that is an algebra error. And I'd like to give you a way to be on the lookout for these types of algebra errors. So let's say you're tempted to do this, sine x cancel like this, and you think to yourself, I'm not really sure if that's right. What you can do is just write out, without the trigonometric function, what you want to do, write what it would be equal to, and then just put in a couple values, a couple numeric values, and see if this ends up being true. So you're wondering, is this the same thing? Well, for example, if w was equal to 1, remember when you write w plus 1 over w equals 1, you're saying this is an identity, this is always true. Well, is it true for w equals 1? Well, if you do 1 plus 1 over 1, you get 2. And that is not the same as 1. If you did w equals 2, then you would get 2 plus 1 over 2. That would be 2/3. Well, not 2/3, 3/2. But in either case, it's not equal to 1. So this is just not true. This gives you a way to go ahead and ask yourself, is this identity, is this thing that I'm writing true? But in order for it to be useful, you have to be, let's say, on guard about your algebra. I remember one time, moving the page a little bit, I remember one time in calculus, I was tempted to say, 1 over x plus y was 1 over x plus 1 over y. And I thought to myself, is this true? Well, if x and y were 1, then this would be 1 over 1 plus 1. That would be 1/2. And is that the same as what it happens to be when x and y are 1 on the right-hand side? Well, on the right-hand side, you get 1 over 1 plus 1 over 1, which is 2. And these aren't the same thing. And so I then convinced myself, I said, oh, better not do that. And then I never made that mistake again. I went on to make other sillier mistakes. Okay, so final piece of advice, you just have to do a lot of these types of problems. Of course, you'll have homework, but if you still feel uncomfortable, then go to the ebook, practice some more problems. The more problems that you successfully complete, the more confident you'll begin to feel, and the more, let's say, sense you'll have as what you can do and what you can't do when you go ahead and start looking at a particular problem.